In this video, we're going to use our laws for combining impedances in order to find the equivalent impedance of this whole circuit. Notice that we don't know what the frequency of our circuit is going to be. They don't tell us that. Instead, they've already converted everything to impedances, so we just have to assume that omega is known, just not known to us. And we're just going to solve it based on what's written. Now, I'll start by combining the two sets of parallel impedances. For the top one, we're going to have 1 in parallel with a minus 2j is 1 times negative 2j over 1 plus a negative 2j. That's a negative 2j over 1 minus 2j. Can't really simplify that much. The other one, we had a 4j and a negative 2j. So 4j parallel negative 2j. Multiply them together on top. Add them together on the bottom. This one's going to simplify a bit. So 4j times minus 2j is going to be a minus 8j squared. And 4j minus 2j is a 2j. So 2 cancels, 1j cancels, and we have a negative 4j for that one. So we can now redraw our circuit here. This first one, again, is minus 2j over 1 minus 2j. I didn't do anything down here. I'm actually, you know what, I might as well take the time, since these are all in series, to go ahead and combine them. Makes my life a little bit easier. So I have a 2, and I have a 6j positive, and I have a negative 2j. So if you combine those by adding them, you're going to have 2 plus 4j. I'll also combine these two up here, 4 plus 2j. And then this one I already combined to get a negative 4j. At this point, I can then combine the two that are in series on the right side. And let's see, what are we going to get? Since they're in series, we add them up. 4 plus 2j, and then a negative 4j is going to make it a 4 minus 2j. Now we have a 2 plus 4j in parallel with a 4 minus 2j. That's 2 plus 4j times 4 minus 2j over 2 plus 4j plus 4 minus 2j. Let's see here on top, I'm going to have 8 minus 4j plus 16j minus 8j squared over 2 plus 4 is 6. 4 minus 2 is 2j. Let's see here on top, 8 plus 8 is 16 plus 12j over 6 plus 2j. I can divide everything by 2 here to get 8 plus 6j over 3 plus j. So that means I now have the following. 8 plus 6j over 3 plus j. And then for the last one, these two are in series. We can add them up. So I would have negative 2j over 1 minus 2j plus 8 plus 6j over 3 plus j. Now we can keep doing the algebra of working that out. I would prefer to use a calculator though. So negative 2j divided by 1 minus 2j plus 8 plus 6j divided by 3 plus j. And this is going to work out to be 3.8 plus 0.6j. And so that's going to be our equivalent impedance here. The equivalent is 3.8 plus 0.6j. And if we would rather have it in terms of polar, we can also do that. Calculators do that really quickly for us. And we get 3.84 angle 8 0.97, so we'll maybe put 9.0. So regardless of which way you write it down, we have found the equivalent impedance just using our series and parallel rules here. You could use Y delta when dealing with impedances. It's possible. It's really something you don't want to do though. Y delta is painful enough when you just have resistors. It's even worse with complex numbers. So if you can avoid it, you really should. Regardless, this is the method. This is how it works.